Hello everyone. This video is about compression of data using Huffman code. Before going to Huffman code, let me explain you about compression. Compression. It is compressing the size of data. That is, it reduces the size of our original data present. Let us represent size of data as number of bits. So why do we need compression? We need compression in order to reduce the storage space needed for data, and we needed to reduce the transmission cost, latency, and bandwidth. So when we are doing compression, we can do it by loss of data or without any loss of data. If the compression is done without any loss of data, it is known as lossless compression. If there is any loss of data, then it is known as lossy compression. In lossless compression, all the information is preserved. It is mostly applied to general data. In lossy compression, there may be loss of some information. It is applied to audio, images, and videos. That is why the clarity of images or videos reduces when we compress them. Reduction of the size of data is as follows. Normally, without compression, there will be 8 bits per byte. But with the effort of compression, we can make it as 2 bits per byte, which is the 1/4 of original size. So 75% of data will get compressed. Few techniques for the lossless compression are LZW, run length encoding, and Huffman encodes. In Huffman, it uses variable length codes based on frequency. Now let us go through the main part of our video. In Huffman code, we give variable lengths for each symbol in order to encode symbols. In this, we exploit the statistical frequencies of symbols. Huffman is efficient if symbols probabilities varies widely, whereas it takes more bits to represent a symbol, which is less frequent. Now I am going to explain the principles with an example. Here we can see frequencies of some symbols A, B, C and D. If we observe the table, we can find that C has more occurrences than all others. But in Huffman encoding, it took lesser bits than all others. If we go to the expected size, in normal encoding, we get 2 bits per symbol. But in case of Huffman encoding, we get 1.75 bits per symbol. If we come to the Huffman code data structure, binary tree is used to represent Huffman code. Edges are represented using 0 or 1. Leaves are represented with symbols. Encoding is done by path from leaves to root. So, if we observe the figure, A, B, C and D are symbols that are placed in leaves of binary tree. Encoding for A is its path from roof to leaf, that is 1, 1, 0. Similarly, for B, the path is 1, 0. For C, the path is 0. But for D, the path is 1, 1, 1. Now if you go to the overview of Huffman code, to encode the data structure, first we need to calculate the frequency of each symbol in file. Then create binary tree to encode compressed file. As discussed in the previous example, encoding of each symbol is path from its root to leaf. Size of encoding will be equal to the length of path. Then save the binary tree. Now let us go to the algorithm to create a tree. First, place each symbol in leaf. Then weight of leaf will become equal to the symbol frequency. Then select two trees, let us say L and R, such that both should have lowest frequency in trees. Now create new node which will have L and R as left side and right side respectively. Then frequency of new node will get equal to the sum of frequencies of L and R, that is left side and right side. Repeat until all nodes merge into one tree. Thus a tree is created. Till now we have discussed how to encode and create a tree. Let us consider an example. In this example, A has equaled 3 times, C has equaled 5 times, whereas E, H and I have equaled 8, 2 and 7 times respectively. Here, A and H have lower frequencies, so create a new node using A and H. The newly created node frequency will be equal to the sum of frequencies of A and H. Thus, the newly created node frequency will get equal to the sum of 3 and 2. Now, the next lowest frequency occurred letter is C. So now, new node is created as shown, and the process continues for remaining symbols. Finally, binary tree is created. Here we can see that all symbols are leaves of the binary tree. Each symbol is represented by the bits as shown. E is represented by 0, 1, I is represented by 0, 0, A, C and H are represented as shown. If we give input as A, C and E, then it will get encoded as shown. This is because A has encoded as 111, whereas C has encoded as 10, E has encoded 01. That's how the output is shown. Now let us go for the overview of decoding. First, we compressed file and binary tree. Use binary tree to decode file, that is, follow path from root to leaf. Here, this code can be decoded as: first, if we take 1, we didn't reach leaf node, so consider the next digit, that is 1. Even though we didn't reach the leaf node, so continue the process until we reach the leaf node. Now we have reached the leaf node, that is A. Then come to the root node and consider the next digit 1. Even though we didn't reach the leaf node, so go for the next digit 0. Thus we have reached the C. Continue the process until the decoding is done. 0, 1. Thus we have reached E. Thus we get the output as A, C, E. Now let us go for the Huffman code properties. It is a prefix code, that is, code of any symbol is not a prefix of any other symbol. If we consider this example, the above mentioned rule is not following, because here I is encoded as 00, X is encoded as 001. That implies code of I is prefix of X. Huffman code can stop as soon as complete code is found. That is, there is no need for end of code marker. It, it is non-deterministic because multiple Huffman coding is possible for same input if more than two trees are there with same minimal weight. Huffman code. Huffman code is a greedy algorithm. That is, it chooses the best local solution at each step and combines two trees with the lowest frequency. It is overall best solution because of the optimal prefix code as we discussed earlier and based on statistical frequency. By Huffman code, best compression is possible. Now let us analyze the complexity of the code. Using a heap to store the weight of each tree, each iteration requires big O of log time to determine the cheapest weight and insert the new weight. There are big O of n iterations, one for each item. So the time complexity of the Huffman's algorithm is big O of n log n. Let us summarize. Huffman code is a technique used to compress file for transmission. Uses statistical coding. More frequently used symbols have shorter code words. Works well for text and fax transmissions. An application that uses several data structures. Now, let us have a quick question and answer session. Question 1. Huffman coding technique is adopted for constructing the source code with what redundancy? Option A, maximum, B, constant, C, minimum, or D, unpredictable. Next question. The time complexity of the Huffman's algorithm is what? Option A, big O of log n. Option B, big O of n log n. C, big O of n log n by 2. Option D, big O of 2n log n. Now, the correct options are: for question 1, it's C, minimum. For question 2, it's B, big O of n log n. Hope you must have got them all correct. Thank you so much.